Welcome to MiPower training series. This video is regarding power system network creation. In this video, we are covering the topics GUI MDB creation, configuring GUI and MDB, drawing SLD for 4-bus network in GUI, and storing data in MDB file. Sample network is a 4-bus network. It has 220 kV grid bus, 11 kV generator bus, planned 220 kV bus, and one load 132 kV bus. A transmission line of 100 km length of zebra conductor is connected between a grid 220 kV bus and planned 220 kV bus. A 100 megawatt of load at 0.9 power factor is connected at 132 kV load bus. The GT is 247 MVA capacity. It has impedance of 14% and its tap range is -5% to +5%, and it has totally 9 taps. The two parallel transformers of 100 MVA capacity are connected between 220 kV bus and the 132 kV bus. The impedance is 10% and the total tap is 17 taps. The auxiliary load of 21 megawatt at 0.9 power factor is connected at the generator 11 kV bus. The plant generator is a 210 megawatt capacity, 0.85 power factor, and its scheduled power is 199.5 megawatt. Utility is connected to the 220 kV bus. It is nothing but the grid. Click on GUI. It shows that at the bottom in the problem 1 folder 4bus.mdb is created and it is configured to the 4bus.GUI. Click on this mesh button. So the grid is coming on the GUI screen. Now click on bus icon, that is a shunt element. Then click on select 220 kV and click on the GUI screen and drag it. 220 kV bus is drawn. So the bus ID is automatically taken by the program. Maximum 8 digits we can give bus ID. It will take only the number. Bus name is the alphanumeric value. Here we can give the number and also the character, but it should not be more than 8 characters. For example, why now we can give this grid 20 kV bus. So bus name is given. Click on OK. So it opens the bus data screen. Here bus number and bus name are inactive. We have already given that one. So there is area 1, zone 1 and owner 1. So in the same area and zone and we have created the bus. By default, for nominal voltage of 220 kV, the minimum voltage and maximum voltage range is -5% to +5%. That is why minimum voltage is 209 kV, maximum voltage is 231 kV. Save this bus. Now draw the another 220 kV bus, that is planned 220 kV bus number 2. You can name it as planned 220 kV. Now draw the generator 11 kV bus. This is the 11 kV bus. Bus 3, this is generator 11. Click on OK and save this bus. Last one is 132 kV bus. Draw the 132 kV bus. Give the bus name as load 132. Save this bus record. Now we have to connect a line in between bus 220 kV and planned 220 kV buses. When we are connecting a series element, we have to click in the middle of the two buses. So here it is showing horizontal. Now rotate. So here click on this rotate button. One click will rotate 90 degrees. Now it is coming like this. Now double click on 220 kV bus, grid 220 kV bus and line 220 kV bus. The line is connected. This is the first element, transmission line, and this is the transmission line data form. So here from bus is grid 220 kV, to bus is line 220 kV. So it is a zebra conductor. We have already selected the libraries. So we can the zebra 220 kV library. Select. So click on, this is a 100 kilometer line. Give 100 kilometer. Click on transmission line library. So zebra 220 kV positive sequence and zero sequence parameters already filled in this library. Thermal rating is 224. User can give the thermal current rating and also the line voltage so that thermal rating can be. So save this record, library record. So save this transmission line library. Here the derated MVA is 224 MVA. So the line loading after running the load flow analysis, line loading will be compared with this derated MVA rating. So if the line loading is more than 224 MVA, then it is a overloaded line. If it is less than 224 MVA, it is nominal loading of the line. Save this. So line is connected. Now connect a GT between plant 220 kV and Gen 11 kV bus. So here also, when you are connecting a transformer, always connect higher voltage bus as the from bus and lower voltage bus 11 kV bus as the to bus. So transformer is connected. The transformer is connected between plant 220 kV and Gen 11 kV. So here we can already libraries are available. Our required library is not available in this list, so that we can create a new library. Give the library number as 30 and click on the library button. So here it is a 247 MVA. (220 by 11 kV transformer. The rated MVA is 247. So primary voltage is already taken as 220 kV. Secondary voltage is 11 kV. So in this transformer, the default taps are 9 taps. So minimum tap number is 1, maximum tap number is 9. So here the tap range we can set. So it is between -5% to +5%. -5% is nothing but 0.95 into 220 kV. That will give you the minimum tap voltage as 209 kV. So maximum is +5%. That is nothing but 1.05 pu multiplied by 220 kV. So that will give you maximum tap voltage as 231 kV. So whether it is a on load tap change or off load tap change, that can be selected. So then the transformer impedance for the GT normally 12% to 14%. So we can give 0.14 pu on its own rating. So for the transmission network, the default X-to-R ratio will be 20. Same can be maintained. So give zero sequence, impedance also 0.14. So normally the winding configuration for the 11 kV side will be delta. The 220 kV should be star grounded. Depending upon it is a YND11 configuration transformer. So we can select phase displacement also. Then save this library. Close the library and come here. So control bus will be the secondary bus. Select that one and save. So the transformer is saved. If you double click on the transformer, so that set tab is 5. Now, since there are 9 tabs, nominal tab will be the 5th tab. The program by default takes the nominal tab, that is the 5th tab. After executing the load flow, if it is required, we can change the tab position. So here at present it has taken it as the nominal tab, that is the 5th tab. Now connect transformer 220 by 132 kV transformer. So connect between grid 220 and load 132 kV. So here we can give the library number as 31. It is a 100 MVA, 100 MVA, 220 by 132 kV transformer. The rated MVA is 100 MVA. So it is primary voltage is 220 kV, secondary voltage is 132 kV. So for this transformer, the total number of taps are 17. So that is minimum tap number is 1, maximum is 17. So the range, tap range is minus 15%. That is nothing but 0.85 into 220. That will be the minimum voltage, 187 kV. Maximum is 1.05 multiplied by 220 kV. That is 231 kV. The impedance of this transformer is 10% on its own rating. That is nothing but 0.1 pu. So give 0 sequence also 0.1 pu. Default 20 can be maintained. Both the winding configuration is both are star grounded, star grounded. Save this library. Now save the data. So we have to connect one more transformer of the same rating between grid and the load 132 kV bus. So we are connecting another transformer. So we have to select the library as 31, save. So here, since the total number of taps are 17, the rated voltage of 220 kV is available at 13th tap. Nominal tap is 13. Same tap we have to maintain for the transformers. So now the transformer is over. Now we have to connect the load. The plant load is around 100 megawatt at 0.9 power factor. Click on shunt element load and connect it to the load. It is a 100 megawatt, 0.9 power factor. Click in the reactive power field, it computes the reactive power. Save the load record. Now connect one more auxiliary load at the generator 11 kV bus. It is 21 megawatt at 0.9 power factor is the auxiliary load. So 21.9, it computes the reactive power as 10 MVAR and save this record. Now connect a generator. At the 11 kV bus. So generator is connected. It is a shunt element. So it is 11 kV. So we can select a library of 210 megawatt generator. The rated megawatt is 210 megawatt. So 210 megawatt generator is selected. Library is selected. So click on the library button. So 247 MVA, 210 megawatt, 11 kV. So whatever the below fields are shown here, these are not considered for the load flow analysis. For load flow analysis, only MVA rating, megawatt rating, and 11 kV rating will be considered. So this data will be considered for the other studies. So at present, it is only these three data will be required for the load flow analysis. So save this generator. Generator schedule power is 95% of the rated megawatt power. It is nothing but 199.5 megawatt. So normally the maximum rating of the generator is 210 megawatt. Schedule power should not be more than real power maximum. So the reactive power will be normally 50% of the scheduled power. As a thumb rule, it will be considered. Then reactive power minimum is 0. For thermal generators, we will consider reactive power as 0 and save the record. Now the utility or the grid will be connected to the grid bus 220 kV bus. So select the utility and connected the 220 kV grid bus. Consider. So here we can select a maximum capacity generator as the grid, or we can compute the utility grid parameters here. This will be considered. So if we select utility, so it is a power rating 100 MVA. Grid parameters, consider 5000 as the three-phase fault MVA, SLG fault MVA as 3500, and X to R ratio as 20 and 30. So save this record. So this completes the 4-bus network. From this video, we have learned how to configure the GUI and MDB, how to draw a SLD for 4-bus network, how to store the network data in the database, that is in the MDB file. Thank you.